This is the BrainSurfer software that was developed by Applied Neuroscience and runs inside of the software platform called NeuroGuide, which is a EEG software platform that acquires EEG from 45 different EEG amplifiers and then allows one to assess the functioning of the brain and to then also train the parts of the brain related to symptoms that are deviant from normal or are exhibiting periods of dysregulation. In this case, we're looking at the brain of a patient with right hemisphere damage, and you can see if we rotate the brain that there's very little activity in the left. This is primarily a focal right hemisphere problem. The symptoms of the patient include spatial neglect and weakness on the left side and general attention problems. And so we have selected the dorsal attention network. And what we're seeing at the surface here is the movement of the brain, of the activity across the surface of the neocortex is generated by the Brodmann areas that constitute the dorsal attention network. We can move the brain with a mouse. We can move it up and down and adjust it so we can view what we wish, because the goal here is to try to isolate and focus on the most deviant and dysregulated parts of the brain, and through brain-computer interface technology to then train the patient, get the patient to modify their own brain through optic conditioning and reinforcement when the brain is in stable states. We can also just isolate the right hemisphere if we wish and just examine it. So we can cut the brain in half. We can do that with the left hemisphere, of course, too. Right now we'll bring it back. We're most interested in these regions of deviation from normal that periodically occur that are linked to the patient's symptoms, and we want to train by reinforcing greater stability these parts of the brain to be more regulated and therefore the symptoms reduce. We can zoom in on these parts of the brain so we know more about them, get a better understanding of where they're located. We can see that there's one especially deviant area here. I right mouse click, we can see that's Brodmann area 8. A right mouse click in this upper part of the gyrus is Brodmann area 6. And another important area that we can see keeps lighting up as deviant from normal is Brodmann area 40. So for now, let's isolate those three parts of the dorsal attention network. For others, this is Brodmann area 39 and area 19 of the visual cortex. But we're mostly interested for now in these three regions, Brodmann area 40, Brodmann area 8, and Brodmann area 9. On the right side. We can also look at the connections between these regions. To do that, we first want to examine the Brodmann areas themselves, which are actually the nodes of the network, of the dorsal attention network that's deviant from normal. Again, this is Brodmann area 8, this is Brodmann area 6, Brodmann area over here is Brodmann area 9, and Brodmann area 40. So what we're going to do is look at the connectivity between these regions by evaluating the coherence between the nodes of these networks. We can completely make the brain transparent and just evaluate the network by itself. Whenever it's blue or green, that means it's dysregulated or deviant from normal. Blue means hypocoherence. It's a type of disconnection, and red is hypercoherence, which is often related to reduced efficiency and speed of information processing. We're going to now bring the brain back to a more visible state, and we're going to zoom in to look at these connections a little bit more, because what we want to do is biofeedback on these regions. But to do that, we need to isolate them and just focus on those nodes that are most significant and deviant and most related to the patient's symptoms. We'll do this by selecting specifically Brodmann area 8 and Brodmann area 9 on the right side and Brodmann area 40. So we'll just isolate everything to these three nodes and the connections between the nodes, so that simplifies things. This is one way in which Loretta's Z-score biofeedback differs from the BrainSurfer, and the BrainSurfer is like a microscope that isolates the most relevant nodes and connections between nodes and allows a clinician to focus on what the clinician considers the most relevant dysregulation of the network related to the patient's symptoms. In this case, it's these particular nodes. We can also evaluate things like phase shift duration. That's what's being seen here. That's the time it takes to allocate resources in the network. And we can train the brain to become more efficient by allocating more resource. We can look at phase lock duration. That's the period of time that clusters of neurons, particularly these Brabant areas and networks, are involved in synchronized communication and information processing. Now we can zoom in on these regions, and through biofeedback and brain-computer interface technology, train these regions to become more stable and exhibit less dysregulation per unit time, and thus improve the efficiency and speed of information processing in a network that's relevant to the patient's symptoms. So in any case, this is an example of the BrainSurfer software that allows one to assess deviation in nodes and connections between nodes and networks of the brain related to patient symptoms, as well as to use biofeedback to reinforce periods of greater stability and greater regulation.